Greetings, my data minions. So today, what we're going to be doing is an interesting thing, and it's a little bit more software-y, but no need to be wary. Man, that was a great intro. Anyways, so we're going to be working with APIs today. It's not going to be anything ornate, but we do need to just have a little bit of information on JSON. So this is a different kind of data than we've worked with so far. So far, most of the data that we've worked with has been tabular data. It's been in tables like Excel spreadsheets or SQL databases, or even like pandas, data frames, things like that, where you have nice ordered columns and rows, and pretty much everything has a value, and it's got a regular shape to it, so on and so forth. But there's other kinds of data too. And so we messed around with this a little bit when we were in Python. And I may have alluded that this day was coming, but it's all good. It's actually really cool, and it's really not all that hard. So we're going to be working with APIs. An API stands for Application Programming Interface, and this is just how we're going to be working with JSON. And JSON is really the focus of this lesson. So if you're a little bit foggy on how the API works, don't worry about that too much. What I do want you to worry about is how we parse JSON, and how that works. Well, so JSON stands for, and sometimes people call it JSON. That seems a little bit weird for me. So I call it JSON. But it's tomato, tomato, potato, potato, tornado, tornado, whatever, however you want to say it. JavaScript object notation. And so you don't need to know JavaScript to use this. The beauty of JSON is that it's actually something that basically, okay, not every, but the vast majority of languages can use JSON. And so we call it language agnostic. It doesn't really explicitly stick with one language or another. And so that works out nicely. And so if you wanted to look at it, what it looks like is a series of, I can turn off dark mode here. What happens if I click that? That didn't help at all. Anyways, but yeah, so what we have here is a series of a dictionary. So we have an object in JSON. In JavaScript, we call a dictionary an object, but it's basically a dictionary. And inside of that dictionary, we have a series of key value pairs. Sometimes those key value pairs are lists. Like you can see here, we got driver standings, and then we've got a whole list of items inside of it. And so on and so forth. So like this is like a really big, complicated, messy dictionary, is how I want you to think about it. But what we end up with is these things, and we basically call them documents, a JSON document. We have a bunch of key value pairs, and a whole bunch of data is stored inside of these documents. Now, we didn't talk about this a ton, but dictionaries are extremely fast compared to lists. We did actually do a little exercise that compared the two. And that means that this kind of data is an extremely fast, reliable way of storing information. And it's also pretty easy to add, remove, and manipulate stuff using our normal dictionary methods in Python, or in JavaScript or whatever other language you're working with, because most languages store things in a very similar way. If you look at JavaScript, it looks like Python dictionaries because it's written basically the same. C++, Java, they all have very similar structures for how they store their data. And as a result, we can use JSON in almost any language you're going to use on a regular basis, which is really, really, really nice. And so that's what we're going to be working with here. We're going to import some packages to help us look at this stuff. We're actually going to be pulling this website, this web page. This is a document it lives online. If you type this into your screen, you can go visit it, or you should also be able to. Oh no, it's not in here yet. So we'll get to that in a little bit. But we're also going to be using the Airgas Developer API. So this is off of Airgas website. They have data available for people to look at, basically. And then if you ever come across API documentation, again, this is very software-y. This is not something that you're going to need to know in any amount of detail. But you'll see here that they have all kinds of directions for how to get the information back. And so that is going to be an important part of APIs if that's a direction you end up going in. If you're like, hey, I kind of like this web development stuff, you want to go more that direction after this, that's just fine. But essentially, an API is just how you connect two applications together. And in this case, the way what we're going to be doing is we have an application here. This is our application. It's a Jupyter notebook, but it's still an application. And then here we have their application, right? So this is their app that lives on the internet, and we're going to let them talk to each other in some way. And what they're going to be delivering is these JSON documents, and so we can pull this information and look at it on our application, and we could do things with that, which is really, really cool. So that's what we're going to be messing with here. But to do that, we're going to need to import some stuff because base Python doesn't have all that we need. And so we're going to import requests, make sure that's plural, and we're going to have JSON. And so it is requests with an S, so plural requests, not singular request. It's a different package. And so the requests package will say, hey, website, can you send me some information? And the JSON package is what will take that JSON and put it into a format that we can actually look at. So here's the URL again. We're going to be connecting to the Airgast F1 Racer API today. It's an API about Formula One racers, the racing series. Very cool. And from the beginning of the World Championships in 1950. You can also check out their topic page on GitHub if you'd like. And we also, if you wanted to use this data for a project later on, you could also download it into CSV format and do some analysis of your own. Would be cool. It would be a fun thing to mess around with. But we're just going to do some pretty mild stuff here. If you are curious and you want to know more information about requests, you can do this. It's not defined. I got to run this one first. Woo. There we go. And now we have a whole bunch of other stuff. So this is our information on requests. You could read that in more detail, but I'm just going to basically show you the most important parts. It's not tremendously difficult to figure out. So I'm going to comment that out. There we go. Now we don't have that huge thing in the middle of our page. And so what I want to do is first I'm going to make a variable called URL. And I'm going to put this link in here. Now, I have the luxury of copy pasting. You will probably have to type this. And it needs to be in a string. So that will work just fine. And so now URL is going to be that value. I need to run the cell. Keep forgetting to do that. Response object. And so what we can do is we can say response equals requests dot get URL. Now, there's four main methods of how we interact with data, and we can most of the time we're using gets, right? So we're just gonna say, hey, I want to get this information, and so what's gonna happen is the requests library is going to go to the URL, right? And we could just pass this string directly in here as well. It's a very common way of doing things, but we'll see soon why we might want to use a variable. But it's gonna go to that URL, pull it back, and save all the information that it gets in response. And so now if I print response, we get back response 200, which is cool, but this means nothing. Give me 1 second. I'm gonna pull something up. All right, excellent. So we get a 200 back, and you say, what does that mean? Well, Mozilla, or MDN, I guess, it's still Mozilla, they're the same thing. They have a page for HTTP response status codes. And so this is something that you may have seen on your computer at some point or something similar to it as you've messed around. And so essentially I'm just telling you this exists because there will be times where if you're trying to pull back data from someplace else, because data analysts and data scientists do end up getting data from other places, and just knowing what these codes are and having a general idea of what they mean. The 100 series just is information that's coming back, and you probably will never have to work with those. The successful responses, the 200 series, those are very nice. That means, hey, it worked, and maybe they'll tell you more information about that. So in our case, we got a 200, so that's okay. We got back what we wanted. It says it's okay, and we're actually getting a good piece of data back from our API. Redirection messages is things like, hey, the page moved, or this URL no longer exists, and I'm going to redirect you to someplace else, that kind of a thing. Client error responses These are ones where it says, hey, that didn't work for a variety of reasons. 400 series usually means it's your fault that it didn't work. Probably my favorite error response ever is 418. You can look that one up. Highly recommend you do. It's entertaining, some of the history behind it. But 400 is a bad request. That means that you didn't send it the right information. 403 request as a return means you sent the right information, but you're still not allowed to see whatever it is. And yeah, 418 is I'm a teapot, and it's just a fun one to check out. Highly recommend it. And then 500 series means it's not your fault. So if you try and get data from an API and you didn't make the API, if you made the API yourself, if you're a web developer and you made the API yourself and you get a 500 back, then it's your fault. But if you didn't make the API and we get a 500 back, then that's not your fault and it's not your problem. It's somebody else's problem, which could end up being your problem as well if you really need that data right away. But ultimately, it's not your fault if you get a 500 error. So we got a 200 back, so everything's groovy. Woo woo. So there's a way that we can actually check to make sure that that worked out right, and so we can actually do response.ok, and it says true. I have never seen this used in the wild for any reason ever. It's just a thing that exists. More you know. But what we want to do is, rather than seeing this, what we want to see is we want to see the JSON, right? So we're going to spit out response.json, and this is a function. So we're going to have those parentheses. We're going to press enter, and sure enough, we get all of this back. Now, this is still an awful lot to look through, so you don't really have to get too detailed with it. But this is right now, we have the fifth, I guess the series 5, the 5th series of the year 2008, the standings. And so again, this is the same thing that we have right here, and that is very nice. Yeah, round 5. There we go. That's what we're looking for. So that's great. Cool. By the way, I just want to point out too that part of the reason that mine looks like this and these weird boxes keep showing up, I have a thing installed called JSON View. It's a Chrome extension, and it helps me. It's a little finicky, frankly, but I can go down here and I can copy the path or the value, and that's actually a really, really useful tool if you're doing a lot of this stuff. But again, the point that I want you to get is a little bit of context for this, a little bit of where this stuff is coming from, and also more specifically how to interact with JSON, which is the real point of this exercise. So that's all just fine. What are we getting back? What is type response.json? Let's see what this is. And sure enough, it's a dictionary, right? Because again, that's how Python's going to read that. We've talked about how this is basically a very large dictionary, and that's really nice. We know how we can work with dictionaries. This is a huge dictionary. It's a lot of data inside of it. And you may have been wondering when we're going over dictionaries, like, man, how deep does this stuff get? They can get pretty deep. Depending on what kind of data you're putting in there, that works out. Also, just as a general data trick, if you're going to put like an image or something like that inside of this kind of data, because this is text only, what you end up doing is like you can put an image on another website and give it a unique URL for that image, and then just put that into your code there like that. And this is obviously the entire Wikipedia page, but you could put the image of Kimi Räikkönen in there like that, and that would be just fine, and that would be how you would actually put images into this kind of data. And then everything else would pull as soon as you said, hey, I need this data. Everything else would pull, and then the image would load from that. It's kind of like connecting the dots with your data. But anyways, all right, we only want the driver standings. So how would we get back just the driver standings? Now, this is where things get a little bit trickier. This is what we're going to be targeting here, is driver standings. And again, I could theoretically just copy it like this, but I'm going to suffer with you. And so here we go. So we're going to go data equals response.json. So we have this, but now we're going to start, and again, this pulls back this whole thing. And so now we're going to start parsing through this. So again, our first thing we have here is MR data. And so that's what we're going to start out with, is we're going to have MR data. Great. And so again, right thus far, and we're going to have this here. Now it's pulling back everything that's inside that MR data. So that's going to be everything in side of this object here, the key value pair. It's going to be the whole value, right? Well, we're going to keep going. So inside of this, we want to get whatever's in the standings table, because again, we're trying to target this. And so we're going to go down and look at the standings table. Standings table. Great. So now we pulled this back, and it's mad because I spelled standings wrong. Great. So now we've got our season, right? Our season is 2008. Our round and our standings list is going to be the next thing we need to access. So we're going to do that next. See what that looks like. Standings list. What have I done wrong? Oh, lists. There we go. So now we've gotten this. We're almost to driver standings. But this is where things get tricky, because you might want to say, oh, I want to put season next, right? And that will throw an error. And the reason for that is it is not a dictionary object. It's not a key value pair anymore. We are now at a list. So if I go back here, you'll notice that we've got that square bracket, and that's saying, hey, we need to index this numerically, right? So we're actually going to pass in 0 here. And now we've got what we're looking for, right? So now we're inside of that list, and we have the 0th object. Because if we go back here, you'll notice that inside of our standings list, inside of this thing, we have our first item here. It goes for quite a while. I think it's basically the whole thing. Yeah, and then it closes right there. But that's good to know, right? So we've got a list item here with this dictionary inside of it. But now we can parse, and we can go to driver standings, right? So we don't want season or round. We want the driver standing item here. So now we can say driver standings. And there we go. So now we actually have the driver standings list. And that is what we actually wanted. Now we could start saying from here, you could say, I just want the 0th driver. And that's going to be the person who's in position 1. But that's Kimi Räikkönen, right? And then we could say 2, et cetera, et cetera. And then we can look and see who is in all the different positions. So that's really nifty. Another cool thing you can do is you can say X, and you can put this in a for loop, which is kind of fun too. So for X in range 5, we'll say, and then we're going to put data response in here, and we can just print data. And what this will do is, because range 5 is going to give us the values 0, 1, 2, 3, and 4. That was really hard to do with my fingers and counting in different numbers. But this X value will be that number looping through. And I can do this, and sure enough, we get them all back one at a time. So position 1, we get this entire dictionary object. And we get this entire dictionary object, et cetera, et cetera. So that's a really cool thing too, and you can parse and get different things back. Like, let's see, what if I wanted to get their name back? So I'm in the driver standings, and we're in this first item here, the 0th item in this list, and I want to get the driver. Is that the right thing? Driver. Yeah, let's see what that does. There we go. So now we get the driver stuff back, and I want the, I think the family name, right? So I'm inside of here now, and I want to get to, yeah, let's do family name. And look at that. So now we have the names of the first 5 drivers. And so that's a really nifty thing we can do as well by putting variables in there, so on and so forth. So that's pretty cool too. I'm going to leave I'll just leave this whole thing in there. I think it's pretty cool. I hope you're having a little bit of fun with this as well, because I get a big kick out of this kind of thing. And this is part of what we'll be doing a lot of with MongoDB. Go away. MongoDB down the road. And MongoDB down the road, and other non-relational data, right? So again, our tables is tabular data, and then you have tables that relate to one another and kind of talk to one another, and that was our SQL, our structured query language, and our relational data. And now we have this stuff, which is sometimes called NoSQL, but it would be kind of a, usually JSON is kind of an overarching term for this. NoSQL, when someone says, oh, NoSQL, this is usually more of what they're talking about. And since you are going to be data nerds, while this might look a little bit different than what you're going to use every day, this is still really important to understand how it works. So we got just a couple other things going on here. Let's try this. So now data equals, all right, so here's what we're going to do. Oh, I don't like that at all. We're going to edit this. I'm going to write out how they did it, and then I'm going to tell you why it's bad. All right, so we're going to say define get racer info. I'm going to pass in data, and you may already have alarm bells going off. New data equals empty list. That's not what I said. Empty list, please. This can go away. Great. And then we're going to say for racer in data. We're going to say racer dict equals empty dictionary, and racer name equals an F string with racer driver given name. We're going to close that off, and we're going to add a space, and then we're going to do another one. We're going to pass in racer driver family name. And so this is going to be, again, this is kind of similar to what we did earlier. And that'll work out. We're going to say racer dict. We have racer dict, racer name, which again will be his, whoever it is going to be their first and last name there. We're going to have racer name, and that's going to be the key, and the value is going to be a dictionary. And so we're going to have first name, and then we're going to put driver given name, and we have a comma here, so we have another key value pair. So the next value is going to be last name, and this will be attached to, oh, I spelled driver wrong. That would have been a mess. There we go. It's going to be driver, family name. We're going to have position. And this is going to be racer position, if I could type. We're going to have wins, racer wins. We'll have date of birth. This will be racer driver date of birth. We'll have nationality. It's going to be racer driver nationality. Essentially what we're doing here is we're going to create our own dictionary here with just the data that we actually wanted to use in the first place. Right, so we haven't looked at that yet, so let's figure out what our constructors are. Constructors are is right here, and we're going to be looking at the name. So it looks like Ferrari makes, Kimi Räikkönen was racing for Ferrari at that point, which is very cool. So that's going to be pulled back as well in our little dictionary here. And then we're going to new data.append racer dict. So again, we're going to have a list. So we've put all this stuff into the racer dictionary for each one of these racers in our data. And we'll be able to do that. And then we're going to return new data. And then we can say get racer info. We can pass in data. Now here's our danger. Data here is currently, it doesn't exist, which is fine. I'm going to actually comment this out and go back to what we had earlier for data, which was just this. And let's just print out data to see what it is. There we go. So again, each racer, quote unquote, is going to be all of this data here. And we have all this other stuff we don't want. Permanent number, code, the URL for a Wikipedia page, don't care. You know, I don't need the URL for the Wikipedia page for Scuderia Ferrari. So I don't need any of that stuff. What I want is just these things. I want the first name, last name, position, how many wins they have, their date of birth, their nationality, and who they race for. And I'm going to put all that stuff in there. And so we're also using racer name here. This way, each of the keys for our dictionary is going to be their first and last name. We put that together here as an F string, saved it to racer name, passed it in. So this is going to be the new key. And then all of this stuff is going to be the value for each of those keys. So this way we can actually parse it by name. Now, the danger and what I don't like about this, and you can kind of figure out why, is I have no clue which data is the real data, right? So like I'm passing data in and then I'm using it as the variable name data, which is a little bit risky. So I'm actually going to call this my racer data. And I'm going to put this here, my racer data. Great, that's fine. And now I'm going to pass this in here, my racer data. And now this is a temporary variable that only exists for the stuff inside of this function, and it doesn't end up potentially overwriting or confusing itself. And I am missing something. Where here? Let's see. Racer name, line 5. I'm pretty sure I'm not missing one of those. Why do you think I'm missing one? That's open and closed. This is open and closed. This is open and closed. Oh. Let's do this instead. That ought to be. There we go. So because I used the double quotations on all of those, it was a little bit funky. But now we have our data here. And you might be wondering, okay, Brandon, why on earth did it matter that much about the variable names? I'm going to write a terrible piece of code just to show you. Give me just 1 second. Okay, so this is why variable names and things like that. And again, you should have figured this out by this point for the most part. But and if you didn't get the alarm bells, that's okay. But you can see here, I have literally no clue. And again, I've been coding in Python for years. I have no clue what's about to happen here, right? Because I said x was 5, and then this is not going to be that same thing as x. Probably what will happen is it will print 7, but I'm passing 9 into the temporary variable x, so it's possible that x here thinks that's the x I'm talking about. This x could also think it's this one. This x could also think it's this one. I really don't know. And I don't really want to, because this is something that you should avoid like the plague, because confusing code is bad. The whole point of writing good code is that it's clean, it's short, it's easy to understand, and it does what you expect. And I have no clue what to expect here, which is why it's bad code. And so that is a small manifesto for how to write good code. Does it make sense to you? Does it make sense to other people? And does it do what you expect it to? That's how you write good code. Anyways, point is, that's why I changed the variable name, because it was mega confusing and I had no clue it was going to happen, and I didn't like that. All right, cool. So last thing that we're going to do here is we're going to write a function that gets different data back. So right here, we're using year 2008. We're using the round 5 data. If I were to go up here and change this from 2008 to, let's say, 16, right? And I change this, and I update it, and sure enough, we get different stuff back, right? So now Nico Rosberg is the one who's back here. We've got a Mercedes in first place, et cetera, et cetera. So you can see that this changes. I can change the round as well, right? Is he still in first in round 6? Sure enough, he is. What about round 7? We can just keep doing this. But this seems a little bit inefficient to me. Yeah, this is taking... Anyways, but you get the idea, right? So every race, these points update. And looks like Rosberg is pretty far ahead at this point in that season, which is fine. But what if we wrote a function that could get this data back for us every time? And that would be really nifty. And we could actually use this get racer info function and put that inside the function as well. So this is a nice little bit of coding. This is pretty clever stuff. But I'm saying get driver info by year and round. I'm going to pass in year and round. Oh no. All right. Who wants to tell me why we have alarm bells going off here? Okay, so that round thing, that is a special magic word in Python. And it actually is a function that does things. So you can just do w3 round Python. And sure enough, lo and behold, we have a round function. This is already built in there, and it will round something to a certain number of decimals. This is also good to know if you're doing data analysis, because sometimes you want that. And now you know that round exists. But that is also why it's a horrible idea to put that in here, because rather than being a temporary variable, it's going to try and actually pass the function in there in the same way that if I were to print round like this, it says built-in function round, right? It's part of Python. And this is not useful to us as a variable. So that would be bad. So we're going to use R instead. And now it will be good. Now it'll be just fine. So we're going to say URL equals, and we're going to use an F string here. And now we're going to type in this whole thing. And we're actually, I'm just going to copy paste this. We already used it once, so you should have it up too. Put that in there. And instead of using the year, I'm going to pass in year as a variable. We can pass in R as a variable. And now what's glorious about this is this F string, every time I run this function, whatever we pass in for the year and the round will be given to this URL, and it will go find the page for us. And we don't even have to load the page in our browser. It will just get that data back based on what it is, which is great. And response will be equal to requests.get URL. And this would be when we might use something like if not response.ok, right? So if we don't get a good request back, then do some stuff. But what I'm going to do instead is we're going to put in if not response.json. And so this is just going to say, again, we've looked at this kind of thing before where if there's data in here, this will be true. If there's not data in there, it will end up being false. And so as long as there's stuff inside of response.json, this code will continue. And it does the same thing as response.ok, which is part of why we would never really use response.ok out in the wild. If not response.json, and we actually want to see if there's specific data we're getting back, mr data, and we're going to look at standings table, and we'll do standings list. I hope I spelled all that right. Lists. There we go. Cool. So we have that back. We're going to return, and this is saying, hey, if there's nothing there, if not false, which ends up being true, two falses makes it true. Only in coding, not in real life. You can't tell multiple lies and make it true. But return, we're going to say we had an error loading your data, and I have a cool MacBook trackpad thing, so I can put in emojis. And ooh, let's add some more. We'll have some fun. And we'll do this one too, if it will let me. Come on, wiki. There we go. Oh, that was too small. I didn't like that. There we go. All right, we had an error loading your data. It is likely the year or round is not in the database. Cool. So that's fine. And so now if we have data that doesn't exist, right? So like if I were to go up here and say, let's look at the year 2027, right? Which maybe this course is still around by then. But it thinks about it, and there's nothing there, right? So it says that there's something kind of empty there. So they've obviously made the data ready for data to populate it, but it doesn't exist yet because it's not 2027, at least from where I sit. So it is likely the year around is not in the database. And again, we have to make sure that there's something in the standings list because there is actually a little bit of data here. And so if we just said this, it would come back true and there would never be a problem, but we wouldn't have any data to go over and that would be boring. So instead, we're just going to have that check. And if the if statement doesn't fire, then we're fine. And so we're going to say data equals response.json. And we're going to say mr data. We're going to say standings table. And we're going to do standings lists with an S. We're going to look at the 0th item there, and we're going to pull back driver standings. And you'll notice that this is remarkably similar to something we've had earlier, right? So again, the data that we're passing in here looks like that. Again, we're defining data inside of this, so it doesn't really matter that it's the same variable now because it's not global, so other things outside the function won't worry about it. And I'm not passing data in, so it's very clear what year and R and data all are because I'm assigning it literally right here, so we know exactly what it's going to be. That's that. We're going to return, and this is really cool. We've done this before where you return a function. We looked at this in our lambdas and recursion and map reduce filter document where you return a function. And but I'm going to actually run this function right here, get racer info. I guess we're returning the calculated data from the function. But this is a cool function. Look at that. Basically, we just said, hey, database, here's going to be a year and round. I want that data back. And if there's data, then go ahead and put it into a variable and crank it out so that we can see things like this from that database. Really, really cool. All in one function. And so now I can say get driver info by year and round. And we can pass in, let's do 2019 and round 4 and see what it does. Invalid syntax. What have I done? Request.get URL. Oh, silly me. It's got to think for a second, and there's our data back. That's pretty cool. And we got all that back, and that's pretty nice. So I think that's pretty rad. We could also theoretically use our little for loop that we had earlier, like this kind of thing, just to get back some of that, if we wanted to. Ooh, yeah, let's do some more fun. I'm way over time for this video, but I'm having a good time. So what I'm going to do is I'm going to actually copy this, pull it back down, put it there. Bing, bing. I don't need any of that, actually. Oh, no, what I'm going to do is I'm going to get rid of this. And instead of these things, I'll get rid of that. And I'm going to make an empty array here. My driver info equals an empty list. Instead of printing that data, I'm going to my driver info.append my data. And then I don't think I need this anymore. Let's just see what happens if I return my driver info. Whee! So we get, this one's obviously a lot more information that we're getting back. But yeah, either one is cool. I think actually I liked the original one better. I think I liked this more. Yeah, that's just a little bit cleaner. But I could also do this. There'd be a way I could do this stuff and only put, like I could use this kind of a thing and only use a certain number of drivers, depending on who I passed in rather than data. I could make my object first and then pass it into that. Anyways, the point is, this is really cool stuff. And it's how you get data back and how you parse non-relational data in a document or a JSON object. Really cool. So your homework is going to be check out this Pokemon API. We've got some good information here. And so this is going to be your URL. And then you can look at Pokemon/Ditto. You can do a whole bunch of different stuff. And yeah, so like this would be the actual results. So this is what it actually looks like. And some other data. If you don't know anything about Pokemon, don't worry about it. You'll be just fine. Yeah, so you can just view raw JSON. Chunk. But this is a little bit nicer because you can actually like collapse and drop stuff. And kind of cool. You can see all the different moves that it knows, which for Ditto is just transform. You also have good documentation that you can look at and see how does this work. Again, the get part should be pretty straightforward. You're just going to have an endpoint of some sort. and have some fun with this. Let's see. Yeah. All you really need to do is get back information for the Pokemon. So that's going to be what we're looking at. And yeah, so you have different abilities the Pokemon can have. You could have different characteristics that the Pokemon can have. What I would recommend would be just pull back the whole Pokemon and then parse down to what you're looking for. And so you're going to be looking for find a Pokemon. Oops. Find a Pokemon, get their name, and get an ability name, and get some base experience, and then the URL for its sprite for the shiny version, the attack base state, HP base stat, defense base stats. These are all things that are going to exist inside of here. If we were to, let's do just Control F real quick and see if we can find some of this stuff. Let's do HP. Okay, it doesn't say it's on the page, but I promise it's in here. Where's our stats? There we go. Look, some stats. I bet we can find some base stats that would be useful here. And obviously we've got some URLs for things, and so if you can find the sprite, et cetera, et cetera. But you are going to have to go on your own treasure hunt for some Pokemon. And if you need some ideas for Pokemon, like you can just Google what are some Pokemon. Or I think they had a link to Bulbapedia somewhere in here. Yeah, so you can go to Bulbapedia. It's like Wikipedia for Pokemon. It's very nerdy very quickly. And there you go, get your berries. You just go to your Pokedex and say, what are some Pokemon? And you can just pick 5 of them. I don't care which ones they are. You might care a lot. I hope you have fun with it either way. I don't know why these pictures look different. But there you go. You got some Pokemon. Have some fun with it. Make a project. Show me some cool stuff. Welcome to APIs and JSON. And I'll see you later. Sorry for the long video, but it was exciting. Bye.